Good morning, good afternoon, good evening. My name is Stephen Truong. Today I present WingBrain to talk about leveraging computer vision and natural language processing for digital health. WingBrain is the company that's doing AI for healthcare. Today we're going to talk about why we need multimodal AI, which is a combination of CV and NLP to solve our problem in our product, which is AIviCare, a telehealth product, and Dr. H is a doctor assistant product for radiologists, hematologists, and oncologists. And the last but not least, we were looking about what future application that we will be applied in the future for WingBrain. So you can see in front of you, we have two imaging. One is, for both of them for kids, and they are challenges for, radiologists today to identify which one is having a disease and which one is healthy. So with the combination of image and the age, it will help the radiologists to identify better and more accuracy the result. So you can see that the first one is, in fact, is the one that having the disease. And the second one is normal and healthy. So what does mean today is imaging data by itself is not good enough. So we need more challenges and fun problems for us to innovate. So our strategy today is, in order to do a good AI system, we must have a big data. And we must have a way to validate early. And we must have a way to give the real-time feedback loop from the doctor and patient. So what WingBrain is packaging to solve a differentiated long-term ecosystem for enable the three things I mentioned. So how we doing that? Basically, you have an AIviCare product today that is serving telehealth with packaging for millions of transactions, in each month, where it's connected between the patient and the medical provider, such as hospital. And this is a model between B2C with the patient, where it's also managing the electronic health record in a central cloud environment. And at the same time, it will connect it to the doctor services. The AI at the core that built for AIviCare, including chatbot, to identify the disease or any serious problem for patients while doing the diagnosis, through the app on phone, and also will guide it to the right doctor. At the same time, if you bring a lot of data so that I can help the Dr. H to do a better job for assistant doctor to do diagnosis and treatment based on, medical image, blood test, and so on. So at the end of the day, the combination of the two products to bring the 4B medicine, including personalized, predictive by AI, participant by large data set, and also a connection of IoT devices through the AIviCare for monitoring, such as, measure the sugar or, SpO2 for the COVID patient, so and so. So today I'm going to share with you the two products. So we'll take about a few minutes for each the demo. So the first one will be the AIviCare, which is for the telehealth. So next I will play the video of Dr. H, doctor assistant for radiologist. Thank you. So the next topic, I will share about how we bring apply multi-model to solving our AI problem. So you can see from the Dr. H system flow today, we bring the edge, mobile, and hybrid cloud to solve the problem. So the imaging came from imaging providers such as GE, Fujifilm, Siemens, send the DICOM file to our edge, which is the VB1 box, where the edge will do reprocessor to make sure the image meet the quality requirements, such as the pixel have to be 512 by 512, and also doing the remove the BII data, which is personal identification data, before it will leave the hospital. And the last but not least, it will do the compression technique so that it can make the bandwidth and more efficient when sending the image. When the image arrives in our cloud, we're using computer vision and NLP based on the imaging in DICOM combined with symptoms such as fever, disease, and demographic data such as sex, age, and the AI will return the result within 5 seconds, and the result can be displayed in our Dr. H application, which is a web app application that can be deployed anywhere, anytime, or the equivalent of Dr. H, which is a PAC system that provided by GE or Fujifilm or Siemens. And after the result display for the doctor to examine, which is radiologist, we also automatically generate the medical report based on NLP and language generation technique. And the report can be examined by doctor using speech recognition and text-to-speech to correct it. And finally, the report able to integrate it into his system, the hospital information system at the hospital design. The technology today we solving from on the way from jet X-ray imaging classification and segmentation that you can see, as well as we apply the explanatable AI where we generate the heat map and also the border where the damage on the lung, so that the doctor can understand why AI identify, the problem. For the MI, we bring the three technology: the segmentation, registration, and also classification, so that we can have, doing the MI analysis with 3 dimension for rectal cancer to evaluate the effectiveness of radiation treatment for patients with rectal cancer before and after the treatment. We apply the registration to ensure that the tumor align together during the period of like 3 months to 6 months of radiation treatment. So that's a very important to make sure the accuracy achievable. Similar concept, we bring it to the same for liver cancer, but we apply for the modality is CT scan. From the technology with the NLP, we apply speech recognition, text-to-speech for the medical image editing. And for the chatbot, we bring it into telehealth product on the AIviCare, so that we can route it to the right doctor based on the symptom diagnosis. And we also doing the extraction of the metadata based on the health record that uploaded through the app by taking like picture or sent by file by different kind of like app, like such as email or things like that. And then the final AI we apply into the AIviCare, is for the auto transcript and taking the personal note for doctor during the consultation online. So from the technology, we bring from beginning like speak to text and text to speech, so that like we bring the information into, like as explained earlier. At the same time, we build a knowledge graph. That is relationship between DC symptom specialist doctor and what DC that we going to deal with for each of the specialists. The conversational AI, including building the natural language understanding, dialogue manager, Q&A system with the embedding, different models such as TF, IDF. And last but not least is a visually rich document where we apply the layout analysis, semantic relationship between entity and location on the form, so that we can have to identify the relationship between entities. For the CV area, we bring the active learning, reducing the noise through human label with auto label, so we can achieve a high confidence through identify the sample data and remove the ambiguity. So we finally achieve about 70% that auto label and only require about 30% doctor label, which is manual label for us. So with the technology we build, we're able to do building the graphical CNN model, where we put the unrelated DC together, such as lung opacity, consolidation, and atelectasis together. The radiomic feature, including 3 key features: shape, identity, brightness, darkness, the frequency space feature, so that we can build classification model for tumor evaluation, such as SVM. And finally, the explanatable AI, where we generate the heat map. So looking forward, what we're doing with the technology, you can see that if the medical image come out by itself, you may identify just possible of 3 DC. but with the combination of symptoms such as fever, it will be able to help the AI to identify, pneumonia is the disease for this particular image with fever patient. And besides the 3D dimension and the combination of CV and NLP, we also bring the time space dimension where we improve the accuracy with the alignment of different like imaging over the historical data for the patient. So with the EHR, we managing a cloud is enabled to do it, on this 3+1 dimension. And for the visually rich documentation, besides vision-based feature and OCR, presentation learning for transfer based and documentation for retrieving, we bring in the combination of vision-based feature and language context. This one of the future that we looking forward to apply for 2022, and that will help to improve the knowledge graph quality. So finally, in the conclusion, the technology we combine with CV and NLP multimodal to bring three things: the alignment of the nature of multimodality in healthcare record. Second, leveraging on the sources of data. And third, bring more accuracy and grounded AI decision support system. Finally, we like to accelerate the value and trust of AI and big data in healthcare. So thank you very much for the listening today. And I happy to be here to present to you. Thank you.